do lesson 5. And let me tell you, this is a new fun concept. We're going to talk about matrices. This is plural for matrix.
Like the Matrix?
Yes, like the Matrix. It's awesome.
I love Keanu.
Oh,
The movie, Matrix.
Keanu. Okay, so here's the deal. A matrix, here's a definition. Matrix is a rectangular array of numbers. Okay? So the dimensions are basically the number of rows by number of columns. Okay, so for example, if it's this guy, A, is a 2 by 3 matrix. 2 by 3 matrix. Nope, 3 by 2, sorry. 3 by 2. If there's 3, -1, 0, 4, -5, 3, and 7. This is a 3 by 2 matrix. Okay, so far so good? So that's a 3 by 2 matrix. Here would be a 4 by 1 matrix. If it was something like this, say B is this matrix. 3, -6, 2, 11. This is a 4 by 1 matrix because there's 4 rows of 1. In A, there's 3 rows of 2. Okay, so this is kind of like a 2-dimensional set of numbers. Yes.
Oh wait, no. Is this a 3 times 2? I can't tell if it's like a.
Yeah, it's a 3, like a 3 by 2.
Okay.
3 by 2 is how you would say that. Got 2 by 4s, that's a 2x4. Okay, so do you see how it looks kind of like a set, but it's 2-dimensional? It's got layers. So this is instead of calling it a set, we're calling it an array. Okay, so these guys are all the elements. Right? There's 6 elements of this matrix. And they have what we call an address. I'm going to put my glasses on because I can't read small things. All right. So, for example, this guy here, this we call this. So we would call the address by basically the matrix name, and then the subscripts would be row and then column. So for example, this 2 would be B third row, first column, and there's only one column. So, and there's no comma, which makes it a little confusing. So that B31 is just B31. So third row, first column. You're not gonna be using the address very much, but if you ever do see it, that's what it's referring to. So what would the address of this -5 be?
Two.
Right, so second row, second column, A22. Okay, good. All right, now you can do operations with matrices. So we're gonna do matrix addition. Basically, you're just adding the corresponding elements. So if I have A1 or A11, A12, A21, A22 plus B11, B12, B21, B22, then your resulting matrix would be A11 plus B11, A12 plus B12. You're just adding those corresponding things. It's much more confusing to describe the rule than it is to just give you an example. And it's commutative. So you can do it either way, it doesn't matter. So a lot of times you will see, you've been using matrices a lot, but you can treat any table like a matrix. If you look at it, well, you probably don't have your books with you, but there's a table in example 1. So at home you can look at example 1. There's just a table that says like 9th graders, 10th graders, 11th graders, and 12th graders. So actually I'll just show you. So if A is the matrix, this 2 by 2 matrix, because remember there's 2 rows and 2 columns. I can say negative A is basically just, it's kind of like distributing this negative sign to everything in the matrix. Okay? So what would negative A be? What would be the first position in position 1, 1? Negative 4, what would be the second one? Positive 15. You're just negating every element. So now what happens when I add these two together?
Zero matrix.
Zero matrix. That's right. So the zero matrix is where every element is 0. So this is like the additive inverse property of matrices. So when you add them together, you get the additive identity, which is the zero matrix. Okay, I'm not even going to bother too much telling you what matrix subtraction is. So I'll just skip right to an example. And just let's do this. This is example 2B. So here is, I want to figure out this. 3, 16, negative 23, 0, minus negative 1, 9, negative 18, 14. Okay, I want to calculate this difference. Okay, well this is kind of confusing, I think, because you're subtracting 3 minus negative 1. Well, that could be potentially confusing. So what am I going to do?
convert the negatives to positives.
Yeah,
Zero.
I'm going to chicken scratch the crap out of that because if I'm subtracting, remember, just like parentheses, so these are kind of like two-dimensional parentheses. If you make that addition, you have to change the sign of everything in the parenthesis, or in this case, the matrix. So if I make that positive, boom, 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 now I just have to add them, okay? Back to what I've always said, subtraction is dumb, so try to avoid it at all costs. It's confusing. I don't want to subtract a negative number. That gets confusing. All right, so this is easy. Let's do that. So 3 plus 1 is 4. 16 plus negative 9, they fight. You end up with a positive 7. Negative 23 fighting against a positive 18 is negative 5. 0 plus negative 14 is negative 14. Okay? That's not too bad, right? So this is that's basically what we talked about before I started recording, was matrix addition. You're just adding the corresponding elements of the matrix. All right?
Okay.
Okay, that's good. All right, so you can just algebra this a little bit and say, for example, here's example 3. 3, 7, 9, 1 plus big fat X equals 5, 9, 2, negative 6. How do you solve for X? Well, let's apply algebra. How do you get X by itself? You have to get rid of everything on that side, right?
Yeah.
How do you get rid of a matrix that's being added?
Subtract.
Subtract that matrix. So we're going to subtract this matrix. You don't have to write it out like this. I wouldn't. Oops, not that. 3, 7, 9, 1. Okay, those will cancel, and you're left with X equals the matrix. 5 minus 3 is 2. 9 minus 7 is 2. 2 minus 9 is negative 7. Negative 6 minus 1 is negative 7 as well. So there's your X. Does that feel all right? See what we did? We were just missing something in an addition problem. So when you're missing an add-in in an addition problem, you create a subtraction problem. Okay, and then it can go through individual positions of the matrix. You could say, let's say that these two matrices are the same. Let's say that this matrix equals this matrix. And you're going to get a lot of these problems on in your homework, and you're going to get them on your test. So here's the elements, or the members of the matrix. A plus 12 is in position 1, 1. 2b is in position 1, 2. Then we've got 23 in position 1, 2, 1. And then D is in position 2, 2. All right, and here's what the other matrix looks like. So it's kind of like a really messed up Sudoku, but we can figure that out. Let's. What do you think the easiest one to figure out first is?
A is 6.
A is 6. Okay, because this has to add up to 18. So let's solve for A. A equals 6. Boom. All right. Are we ready for B yet?
Oh my
Sure.
gosh.
Negative 7.
Oh my gosh, what?
It's just. Oh, I can't remember. What does that say? 6? A6?
Yep, because A plus 12 has to equal 18, right?
Yes.
So A has to be 6. So B is negative 7 because 2B has to equal negative 14. So B has to equal, so it's just 4 different equations you have to solve, and these are never going to be too difficult. So then you got this 23 equals A plus C. Are you ready to solve that yet?
No.
No, you have to wait because you don't know what You don't know what C, well, you do know what A is, so you could figure out what C
You could do
is.
6
Let's do that.
3 minus 6.
So A plus C has to equal 23. Now A equals 6
That's a
plus
26.
C. Oh, that's right.
So what is that?
Is that a free problem set?
Yes.
Oh, see how I was thinking of the 6? Yeah.
Yes.
Yeah.
You were-
I'll give
I
you a free
understand.
problem. I'll give you a free problem set. So 6 plus C equals 23, right? So do you see how you can't do that one first?
Yeah.
Because you have to figure out either what A is or C is first. So now that we know what A is, now we can figure out that C is, what is that, 17? Okay, and then D, that was a nice one. D equals 3. What's happening?
Attention all teachers and students, if I could have all 10th graders come down, photos.
Can't go faster.
Is that 10th graders? You guys 10th graders? Audrey. Okay, the only other one is scalar multiplication. So you can like double each one. You're just basically you're doubling each one. I'll tell it to. I'll just figure it out later. Just watch the video, Audrey. This is where you need to start watching. Okay. All right. So one more thing in lesson 5, and this
You're
is.
not erased it yet.
Sorry, I erased the most. Oh, I didn't. That's it, right there. That's what we just did.
Yes.
You did erase a little bit. Yeah.
What?
So,
Did I erase the wrong thing? Oh, a little bit.
Just trace a little
It
bit of the box.
C equals 17.
but what is 6 plus C equal?
23.
Yeah.
Thank you, sorry. I'm going fast. Problem.
You're okay. You're okay. So a scalar, you know, like the scale factor or things like that. Same word. A scalar is a constant by which a matrix is multiplied.
I just, oh gosh, I already lost my. Oh, what? What is it? Scalar?
A scalar is like what you multiply something by. Okay, so usually we talk about scale factor. Like, you know, the little model airplanes on the box, it says like X30, which means that it's 1/30th of the actual size of the airplane or something. Okay, scale factor. So a scalar is the term used when you are multiplying a matrix by something. Okay. All right, so if I have n outside, it's kind of like the distributive property, right? N outside of a matrix, here's A11, A12, A21, A22. Then your result is just going to be n times everything. So n times A11, n times A12, n times A21, n times A22.
How are we gonna know that, like, we need to distribute that?
Because it looks kind of like a, you see how it's like a parenthesis there? Like,
so
remember,
Okay.
like back in algebra when you had something. Let's do one more example, okay? You guys ready?
Yes.
So I'm gonna just say 3 times this matrix. So 1, 2, 3, -4, -5, -6. So there is a 2 by 3 matrix. So what does this equal? Well, just distribute that 3 to everything. Okay? So now we get 3, 6, 9, -12, -15, -18. That's it. So this is, if this is A, then this is what 3A would look like. So if you're asked to find 3A, well, multiply 3 times every member of the A matrix. Okay? Does that work? All right.
Flack math! Give me some math and I'll give you some flack. Flack math!